Alrighty, today guys we're having a look at fractional indices, and as I've done previously I want to refresh our memory on some of the other laws that we've used so far. So we know that if I multiply two terms that have the same base, I add those indices. Okay, if I do a division, a to the n divided by a to the m, I go a to the n minus m. If I've got 1 over something, that's just a to the minus 1. If I've got something like b over a, that's b to the 1 times a to the minus 1. And if I've got something like a to the power of m all to the power of n, well then that is just a to the m times n. And of course we had, if I've got a to the 1, that's just a, or a to the 0 is 1. We've done all those. If you're unsure about any of them, go back and have a look at some of those previous videos, but that's just our quick refresher. So today we want to have a look at fractional indices. So I want to be able to get to a point where we can say a to the half is equal to something else. I'm going to leave a question mark there. So we'll start off with, if I have something like this, 5 squared, and I go and square root it. Well, we could go and write that as 25 being 5 squared, and then we'll end up with square root of 25 is 5. Similarly, if I have x squared, all being square rooted, well then that's just x as well. The inverse operation of a square root of a square is a square root, so they'll just cancel one another out. So looking at it this way, if I turn this square root here, I want to work out what power a square root is. So I'm going to turn that into x squared to some power, and we know the answer is going to be just x. Okay, that's literally translating this one into a different form. Well, if we look down at this rule, well, I know I'm going to have to multiply these indices. Okay, well, I want my answer here to be 1. I want to end up with x to the power of 1. So 2 times what gives me 1? Well, my power has to be a half. So I hope you agree with me that x squared all to the half would give me x to the 1, which is just x. Now, if we look at these two expressions, sorry, that colour is not great. If we look at these two expressions, what I think we'll see is that they actually point to the same sort of idea, that if I've got x squared being square rooted, I get x, or x squared all to the half, I get x. Well, I hope what you can see is that we end up with x to the power of a half is the same as the square root of x, and we're going to add that onto our little list of index laws. Okay, so that means if I have something with a half power, it ends up being a square root. Now I'm actually going to extend that out a little bit. Not only do we have the square root of x is x to the half, the cube root of x is x to the power of 1 on 3. And the fourth root of x is x to the power of 1 on 4. We can prove all of these by going and saying if I had x to the 4 raised to some other power, what would make that x to the 1? Well, that would be a quarter. So whatever this little number in front is here, within the square root symbol. Now I don't mean something like this, 2 times root x. No, I mean this, where it's actually sitting in the square root, the radical symbol, not sitting at the front and multiplying it. So just know the difference between those two things there. And to add one more thing to it, if I have any root of x, that is just x to the 1 over n. Okay, that's sort of our other rule for now. So if I have x to the power of 1 over 5, that's just the fifth root of x. So what we're going to do, I want you to write some of these with the square root symbol. Okay, so I've got 6 to the power of a half. Well, that's just going to be the square root of 6. Now, if I can simplify that, I should, but we know that 6 is a product of 3 and 2. So there's no simplifying I could do there. If I had 16 to the power of a half, well, I could just simply rewrite that as 4. What about if I've got 2 to the power of 1 over 5? Well, that would be the fifth root of 2. What about if I've got something like this, 3 to the power of minus a half? Okay, well, we've actually got two things going on here. I've got a fractional index. So this bit here is going to make everything square rooted. And this, what does a negative index do again? Well, a negative index means that I just go and say, I've got a to the minus 1, that's 1 over a. Okay, well, no difference here. We would go and say, this makes it 1 over 3 to the power of a half. Now it's not 3 and a half, that's 3 to the power of a half. Well, the other way I can write that is to go and say that's 1 over the square root of 3. Okay, so that one's getting a little bit more challenging, but ultimately, whatever power I'm dealing with here, if it's involving a fraction, this denominator of my fraction will come out the front of my square root symbol. Let's say we want to go the other way. Let's say I want to write something like this, the cube root of a with a fractional index. Okay, well, I've got a to the power of 1 over 3. Whatever number is within my square root symbol is my going to be the denominator of my index. Let's say I've got the fifth root of b. Well, that's just b to the power of 1 over 5. What if I've got 3 times the root of n? Well, that's just 3n to the power of half. This 3, it means 3 lots of. Okay, that's 3 times not in there. Okay, it's not in there. So that's just a normal square root symbol. I've actually made a mistake here. That should be 1 over 2 because it's a normal square root, not a third root or a cube root. What if I've got something that looks like this? 1 over root x. Okay, well, there's two things going on here. I hope we see that we could write the root x as 1 over x to the half, and that would be x to the minus a half, because I'm just taking 2 steps. I get the half because it's a square root symbol, and then I get this negative because it's been 1 over something. One last one, for if I've got minus the square root of b. Okay, well, that's just going to be minus b to the half. This minus symbol at the front, that just means it's a negative term. Okay, that doesn't actually impact our indices, that doesn't impact how we rewrite it as a surd or as a fraction. It just means that the whole thing is negative. So we would just leave the negative symbol at the front, and we would deal with this one using our new index law. All the same rules apply. So if I've got something like this, b to the half times b squared, that would literally be b to the power of 2.5 or 5 on 2. There's no difference in how we deal with that sort of problem, and I hope you'll see that as we go through.